Welcome back, Math 30-2. Today we're going to look at data and applying polynomial functions to it. So it's going to be very similar to what we did with exponential functions and logarithmic functions. Now, if we remember those, we ended up doing something called a regression. And we had to know what graph looked like an exponential and what graph looked like a log function. So here we're going to have to know what graphs look like polynomial functions. And we've kind of looked at what polynomial functions look like before, but now we're given data and we have to figure out, hey, what kind of polynomial function is this? Is this a cubic function? Is this a quadratic function? Is this a linear function? Or, when you come to your diploma and stuff, it could be also an exponential or a natural log or logarithmic function. So you have to know what all those graphs look like. So we're going to start off by just doing this here. We're going to plug in all of these. So time is going to be my x. So I have 0, 1.5, 3, 4.5, 6, 7.5, and 9. Go over, and we put in my y values, which is my concentration. So here I'm going to have 0, 26.9, 41.2, 47.8, 46.0, 36.8, and 20.3. Make sure they line up. Yep, everything lines up, so we're good. Okay, so now I have all my stats in. Okay, but I have to see what they look like on the graph. So I'm going to graph them, go to my y equals, go to my y equals, and put on my stat plot. Okay, so stat plot's on. Now, I'm going to see what I should be, what my window should be. Well, my x min, I'm going to put at 0 because I don't go lower than 0. My x max, 9 seems good since 10 seems good since 9 is my biggest. My y min, well, I'm going to put this at 0 as well since it's 0 there. So I'm going to put 0 for my y min. My y max, I'm going to say 50 because 47.8 is my biggest. Now I'm going to graph. And there I get my data points. So my dots kind of look like this. And looking at that right away, I know that this is going to be most likely a quadratic graph. Quadratic will work best for this one. Okay? And that's it. Also, and here's just going over the regression, but also, later on, we're going to also do graphing of sine and cosine of data as well. So you're going to have to know what those graphs look like. So this is going to tell you how to put it into your calculator, which we've done earlier, so it's kind of the same way as what we just did. Now we're going to go quickly to example number 1. So here we have our time t hours, okay? So once again, it's concentration. We're doing a concentration of medication. So we have time in hours, and we have the concentration. So let's try and first do this data. So I have to go to my stat list, edit it, clear both, don't delete, always clear. If you delete, you're going to actually delete the list and you have to go back to your and put it back in. So let's take a look at this. So my x values are 0, enter, 1.5, 3, 4.5, 6, 7.5, and 9. So actually my x values are the same. Didn't really have to change them. Now my y values are 0, 26.9, enter, 40, 41.8, 41.2, 47.8, 46, 36.8, and 20.3. So same thing. It's kind of like what we did before. It was already in there. And my x and y are going to be the same. I graph it. I get a graph that looks like that. Now, using the graphing calculator in the two lists, it wants us to put in a quadratic formula. So determine the line of best fit. Now, if we remember how to do that, I'm just going to go to my stats. Oops, I can quit. So stat, and we're going to calculate, and we know this is a quadratic regression because it looks like a quadratic formula. Put it down, and I end up getting, there's my a value and everything like that. So it wants it to 2 decimal places. So I have this here. I have c is equal to negative 1.89 t squared. And then we have plus 18.76 t plus 1.21. So that is my equation. Now it says, on the calculator, display the graph of the regression over the scatter plot. Use the graph to solve the following. Okay, so let's view it. There it is. And we're going back in here. And if we remember how to put that equation in, we have to go to vars. And we want the y variables. And we're in 5, statistics, because we used the equation. Enter. Okay, and then there we go. It does the last one. We have to do this first on the main screen. Otherwise, it's going to use the wrong thing. So I had to do in this screen my statistics and do my regression. So then it knows which type of regression to use in this. Now, if I want to do any calculations, I have to turn off my stat plot. So here is my graph. And it fits so nicely. Okay, so what is the domain and range of this function? So the minimum value is 0, and the maximum value for the time to intercept the graph where is no longer medication in the blood. So determine the domain of this function, my domain. Well, we want to know the domain of this function. I take a look at this. My domain is all my x values. Well, I start there, and where does 0 hit? I have to make my x look bigger so I can see where my x-intercept is. So I'm going to put 15. Let's see what it looks like now. There we go. Now I can see that. Now my window, I'm going to go my y to minus 10. Okay? So that way I can see a little bit below. Because I'm going to have to find my domain, I can only go from 0 to when we're out of, well, my concentration is gone. So let's try and figure out when that is. So what do we have to do? We're going to have to calculate my 0. So we want left bound. Here's left bound, then we need right bound, something there, and we need our guess. And it's around there. So I end up getting, well, 10.2. So at 10.2. Okay? So we get 10.2 is my, from 0 to 10.2. So we have 0 has to be greater than or equal to 0, but less than or equal to 10.2. That is my domain. Now, what is my range? Okay, so we have here determine, so it says determine the domain for this model. It is all the way in there, where x is an element of all real numbers. Because we go from 0, when the time starts, we can't have less than 0, and after 10.2 hours, we'll run out of concentration. Okay? The medicine. So let's take a look at number 2. It says the doctor decided that the patient needs a second dose, and every time that the concentration is less than 10 milligrams. So every time it's less than 10. So my y value, we want to know where 10 milligrams is on this. It's going to take us forever to check, so I'm just going to put my y value is 10. So we want to know where it's equal to 10. And then he adds more. So right here, he's going to have to add more. So we're going to have to go second, calculate, and we find the intercept. So we want the first curve, more or less where it is, and we're about here. Enter, enter. I get, when y is 10, we get 9.6. So we have 9.6 hours. So 9.6 hours from now, we must give a redose, because that's when it's 10. So it has to be after 9.6 hours, or just before 9.6 hours, because he doesn't want it ever less than 10. But we're starting at 9 a.m. was the first dose. So 3 more hours will give us 12 a.m. or 12. Then we need another 6 hours, so that will give me 6 p.m. But we have 0.6 hours. Now, how much is 0.6 hours in minutes? So I go 6.6 multiplied by 60, because there's 60 minutes in an hour, which will give me 36. So that is at 6:36 will be when he gives the next injection. So at 6:36 or before 6:36 p.m., he has to give the next injection, the doctor. Because as soon as we wait longer, it's below 10. Okay, the concentration is below 10. And that's it. All right, so I just added 9.6 hours to that. But I had to put the 0.6 in terms of minutes, and that's 36 minutes. 0.6. So let's take a look at example 2. So example 2 says, a research student was investigating the following relationship. Draw between satisfaction. So here we go, and we have this graph here. Now, the data from 12 different employees is given. So the job satisfaction is measured from a scale of 1 to 10, and productivity is a scale of 1 to 100. So we have job satisfaction versus productivity. Okay, seems like good research. Now, what we want to do is we have to put all of these into my stats, figure out what this looks like. So I'm going to clear both, do not delete, once again, just clear, go back in, and we're putting in each of these here. So my x, we have 3, enter, 8, 7, 5, 9, 10, 8, 2, 5, 7. And productivity, we have 44, 81, 75, 66, 90, 70, 71, and 98, 75, 25, 68, 77. Okay, good. Now, we go into my window, because we're going to graph this. Put on y equal, put on that, but window. Now, if I take a look at this, my x is my job satisfaction, right? This is always my x. And it's between 1 to 10. So I'm going to go between 0 and 10. Now, I take a look at the next part is my productivity. My productivity is between 1 and 100. So I'm just going to go between 0 and 100 for my y. And now I'm going to graph it, and it looks something like that. Very similar to this here. Okay, I might want to go my window just so I could make sure I see everything. Put this to 12. Yeah. So now I could definitely see everything. All right. So that's what my graph looks like. Then it says, student looked at the scatter plot and suggested it could be a linear. So let's try a linear function first. So we're going to quit, and we're going to go into here. We're going to calculate. And the student thinks it's linear, which makes sense. You can make a line that goes like this. It looks kind of linear. Linear. And there is his equation. So it wants to know everything to 2 decimal places. I'm just going to put that right here. So let's put this into 2 decimal places. We get P is equal to 7.91A plus 19.90 or 19.89B. 19.89. Well, that shouldn't be A, that should be J. Okay? Now, let's see what this looks like to the data. So I'm going to go second. Oops. Go to statistics. We want a regression. And we graph it. So my line of best fit using that regression looks like this. That's kind of accurate, but another student looks in and says he thinks it's a cubic function. So let's try it now if it's a cubic. So I'm going to quit this. Oops, first go there. I'm going to clear it. And let's see what happens if we do a cubic. Okay, I made sure I did this first, so then when I graph it, I need to see this cubic function here, because the calculator will now graph a cubic regression if I put in my y. I do that bars, okay? So here we have P is equal to A, which is 0.32J squared minus 6.37J, and cubed, that's cubed, squared, plus 45.90J minus 44.21. Okay? Now let's see what this one looks like if I put that in here. I'm going to go that, statistics, so I did it already. And hit that, enter. I want to graph it, and look at that. This one matches perfect, because there's a little point of inflection there. So there is actually a point of inflection on this graph. So which one matches better? The cubic. The cubic does, because there's a little point of inflection. It works very nice with that. Okay? So there we go. So right now, I want you guys to start doing questions 1 to 8 as I see you tomorrow as we work on these questions together.